In this video, we're going to have a look at an 8-mark exam question that I pulled out that looks at resultant forces and just forces in equilibrium in general. It tells you to start with that there's a block of weight 10 newtons, so I'm sure you guys know that weight acts vertically downwards. It's at rest, so that's very important because at rest it means that the particle is in equilibrium. In equilibrium, there's always 3 facts that you can use in A-level maths. Sorry, I just realized my pen's very thick for some reason. But you can use the fact that resultant force is 0 horizontally to form an expression. You can use the fact that resultant force is 0 vertically to form an expression. And if there was to be multiple forces at multiple distances along the line, then you can use moments as well. But here it doesn't really make sense because we're talking about all the forces acting on one particle. In this case, it tells you the angle is inclined at 26 degrees. And the block is on the point of sliding down the plane. That means that it's not sliding yet, so it's still in equilibrium. Find the coefficient of friction between the block and the floor. Well, first of all, we need to think about what direction the friction would be in. If the block is about to slide down the plane, then it makes sense that friction acts opposite to the direction of motion. So in this case, it would act up the slope. Friction is equal to the coefficient of friction multiplied by the reaction force where the sort of mass is placed. We don't know the coefficient of friction, that's what we're trying to find. And the reaction force, which would be perpendicular to the surface, we also don't know that. So I'm just going to write mu r now for friction. Now, what we can use is the fact that this 10 newtons, it can be split into a component that's perpendicular to the slope and the component that's parallel to the slope, so going down the slope. And that's going to be very significant in this question. Now, if this angle here is 26, this angle here would also be 26. I'm going to briefly explain why, but if you guys already know why, feel free to skip 30 seconds. So it's because in this triangle here, we have a right angle triangle when we drew this perpendicular weight. 90 plus 26 is 116. 180 minus 116 is, my mental maths has gone horrible, it's 64 degrees. And we can use the fact that this component is also at right angles to this slope here. So we can do 90 minus 60, 64 again, and we get 26. And that's why this angle here is 26. Great, I'm just going to undo some of that because it's getting a little bit messy. But what we can say is because that angle is 26, the component that's adjacent to that angle or touching the angle is always the force that's acting, which is weight, multiplied by cos of the angle, which is cos 26. And the component that's opposite the angle 26 is the force that's acting, which is 10, but in this case sine 26. So here we don't really take resultant force 0 horizontally and vertically. Instead we take resultant force 0 parallel to the slope and perpendicular to the slope. Again, we can assume this because it's in equilibrium, so there is no motion in all directions. And the reason we're taking it in these directions is because these are where the forces are acting in the diagram. So forming the expression for expression number 1, we can say that parallel to the slope, we have the force going down the slope, which is 10 sine 26, is equal to the force acting up the slope, which we've determined is this friction that we don't yet know the value of. There's 2 unknowns here, we can't really find the coefficient yet, so let's form the second expression, the fact that resultant force is 0, perpendicular to the slope. That means that the reaction force would be equal to the component of the weight that acts perpendicular to the slope, so that's 10 cos 26. And now that we've got that, we can actually just input that into this to find the value of mu. So rearranging this, mu would be 10 sine 26, what's on the left hand side already, all divided by the reaction force, which we've just established is 10 cos 26. You can put that into your calculator, or if you've been a bit perceptive, I'm sure you guys realize that 10 cancels out with 10, sine over cos is tan, so you can just put tan 26 in your calculator, and what you'll get is 0.49, which is the coefficient of friction for this question. So once you break it down and label all the forces in the diagram, you kind of set yourself up and you can use the fact that resultant force is 0. Be sure to leave a like if this video did help, and yeah, subscribe, I'd appreciate it a lot. Thanks for watching. Thanks for watching the video, guys. Hope it helped. If you have any A-level maths or physics tutoring inquiries, be sure to send me a message at www.excelineducation.co.uk.